Had linear programming, like I said. So what does this mean? Now this is very simple, right? And no, it's not really simple in solving. Yeah, but it actually the concept itself is a very good concept. What the linear programming here, what it helps you in the production line is that it helps you to choose the best combination of limited resources, right? Let's say I want to do a project, I want to produce an item, a product, and then I have so many. I want to buy materials, I want to buy, there are resources I need to put this together. So, actually, what I'm trying to do, I want to get a material that will be at a minimal cost. You understand? It helps you to minimize cost and then maximize your profit. So that whatever I'm doing, I have to just focus on minimizing my cost and then maximizing my profit. Now, this is what they say linear programming. That means using a linear line, linear equation. That's what it means. So by the time you have the resources, you put them on a linear equation and they're able to solve and you get the answer. Then what the answer is given to you, they call that answer optimal uh, answer. So I will we'll just go over it to just see maybe from the material here where they said you can see. So a linear programming is a constraint optimization where the constraint and the objective function are all linear. And it is called programming because the goal of the calculation help you to choose a program of action. A linear programming is a process of taking various linear inequalities relating to some situation and finding the best value obtainable when under the under those conditions. So we'll look at it. We have the definition, this here, all these things. You can go through the material on your end and then you understand the simple questions here, all that. So me, I will just teach you guys how to solve something like that, right? We have a question, like I said, I'll go to the past question papers that we have, right? So I will just show you a question that when you see such a question, you know that this question is linear programming. So this is one of the question here. So this is a past question paper of 2022, right? I'm very sure you can see my screen. If you're not seeing my screen, if you can't hear me, please you let me know so that I can pause, right? Together. So a dentition wishes to mix two types of food in a such a way that the vitamin content of the mixture contain at least 8 units. Now you take note of the unit of the data that you've seen. Now we look at first of all we are looking at they said the mixture contain 8 units of vitamin A and 10 units of vitamin C, right? So that is now really you had to even understand the question first before you even think of answering the question. It said a dentition wishes to mix two types of food. So now you start thinking like this different kind of food now. Now in such a way that vitamin contains in a such a way that vitamin content of the mixture contain at least 8 units of vitamin A and then the 10 units of vitamin C, right? Now, food one contains 2 units of what? Kg of vitamin A, and then uh, 1 unit 1 unit per kg of vitamin C. That is the food one. Then food two contains 1 unit per kg of unit A and 2 units per kg of unit C. Now it costs 15 naira per kg to purchase food one and it costs you 70 naira to purchase uh, another food, which is food B. Now they said formulate this problem as a linear programming problem and solve the issue. Are we together? We have gotten the question that we have to solve. And this question alone, it's 12 marks, 12.5. And imagine you have your quiz like 30. Sorry, you have your quiz like 20. This one plus this one complete like that is 32 already. Okay, so now we have to take it step by step. and then let me do use Excel because it will help us to solve it out. So now the question. Let me get the question. Where is that question again? Okay. That question was supposed to. So, okay. So what I need to get this question like this, so we can use it here. Put in the question here, so we can see it. Okay. So now you want to, let's assume you are the one to do this one, right? You're supposed to mix this food, and what I want you to understand is like you need to understand the problem that you have. Now we need to, let's say we are doing it now together. We need to mix two food. Yeah, you need to meet two type of food, and then this food has to meet vitamin requirement at minimal cost. What we are looking here is we are looking at, we supposed to do this, but what we are trying to do, we are looking at which one. How are we going to get the minimal cost of producing this thing we are looking at? We don't want to spend too much. So now to get the, let us get our data ready. Let's okay. For the first food, this is like if you're solving an exam. Let's say you have to solve this. You have to, like, the step have to be there. So let's just say uh maybe given data or given information. Given data, or let me just say information, right? Something like this. So given data or information, we have food one, right? We have food one. So in the in this food, what do we have? We have the food contains what? The food one contains 2 units. Yeah, 2 units of, yeah, contain 2 units of vitamin what? A, or vitamin A, right? So it contains 2 units of vitamin A, right? That's 2 units per kg of vitamin A, and then comma 1 unit of vitamin C. Yeah, 1 unit of vitamin C, 1 unit of vitamin C. Okay, so that is for food two, and the cost. Now the cost of it. At what cost is this guy costing you now? Let's look at food two. The cost of it, and everything that you see there is going to cost you 15 naira per kg, right? 15 naira it's per kg, right? 15 naira per kg. So we now look at another food, which is food two. Two now is going to be, it contains 2 unit, how many? For two, it contains 1 unit. 1 unit
Yes, 1 unit vitamin A, 2 units
vitamin
vitamin C.
vitamin A, right? Okay, nice. So it also, 2 units, but the question is already looking somehow wrong because it says they are having the same thing. Because this one was 1 unit of, okay, like it's now, because this one just interchange the whole values. The other one is two of vitamin A and one of vitamin C. This one is 1 unit of vitamin E and 2 units of vitamin C. Okay, 2 units of vitamin vitamin C, right? So now we're looking at the cost, and the cost of this one It cost us 70 naira, right? Cost is 70 naira per kg, right? So 70 naira per kg. Okay, so now we have, let's say we look at the data. So what is the requirement? Let's say what is required now. At least 8 units of vitamin A or at least 10 units of vitamin C. Look at it. This is what is required. So they said when you mix the food, by the time you mix these two food in such a way that vitamin content of the mixture contain at least 8 units of vitamin A and 10 units of vitamin C. So that is the requirement. That is what is required. So we'll say, okay, this is requirement. So here we're now looking at least uh, 8 units of vitamin A here. Vitamin A and then 10 units of vitamin C. Okay, so now let's look at our variables, right? Remember, it's linear, and we need to. He says you should formulate this. If you formulate this problem as a linear programming, so now we need to formulate this in a linear equation. So what we need to do now is to say, okay, let's assign our variables, right? We want to design decision variables, so we can say, okay, x1. This is we have variables, right? So we have x1 and x2. So this is x1 and x2. That are those variables. So what is x1? X1 can be kilograms of food one. That is where we have two food now. So this x1 should be our food one, and f2 should be our food two. Get now. So this can be like kg of food one, and then this one will be kg of food two. Okay. So now these are our variables. So now what we need to do now, we need to formulate the our this thing now. We use the variables to formulate this, right? We use the variables now to formulate this thing. So we need to look at now what are we doing? We need to formulate now. If you go to this course material here, uh, where did I open it? What's in like here? Okay, so I just want to show you where the equation is written. So this what is called objective function, right? This what is called like this called objective function, and then I'll show you like all this stuff. I'm looking at into this written here. Should be up. Can you see? So now what we're trying to do, a linear constraint means no diminishing or increasing return. Now adding more input give the same effect on output regardless of how much you are already making. So no negativity constraint. The process level cannot be less than zero. So this means that you cannot turn your product back into resources. So objective now what we need to do, we need to create an like the solution, like the problem we have our variable. So now we want to formulate the objective word function. Now, what is it? We use that to because we want to minimize the cost. Yeah. So we need to get objective this thing, function. So this function is used to be minimized or to be maximized. So when it comes to now a linear objective function means that you can say all you want, all you want of your output without affecting the price. Now you have elastic demand in economics, all this one, forget it. All these things is English, right? Coming to back to the question, I just wanted to see that the word I'm using, objective function, is something that is so now here we want to minimize, right? And the objective function is actually denoted by Z, right? So here we want to minimize. So here we want to minimize our cost. So Since we want to minimize our cost, which is Z, we now have to say, okay, Z is equals to, let's go into the function. So this is going to be equals to Z. It should equals to 50. 50 is X1. We are looking at the cost. Yeah. Now, this is, we want to minimize our cost. Let me say minimize cost. So we are looking at the function that we are using to minimize our cost, which is the cost for food one is 50 per kg, right? And then the cost for food two is 20 per 70 per kg. So we now have to say, okay, this is what I put here is 50x1 plus 70x2. You get now? So this is the function that we have. So now this simply means like what we're having here is right. What we have here in simple explanation for us to know that we now have to say, okay, our cost now for each food is going to be equals to, let's just say, we have we have 50 we have 50 naira, right? We have 50 naira per kg of what food one, and we have, let me just use plus so that since we are doing that, and plus 70 naira per kg of food two. Really, do you understand? So this is just what we have here. This is what the objective function is telling us. So now we look at the constraint, right? We look at the constraint. So now what are constraints? If you may ask. So looking at the constraint, and then before we start that is we look at the constraint. And constraint is very simple, right? Constraint are just, constraint are restrictions, limitations. Do you understand? So here now in this our example now, right? Example, a constraint here just it actually it tells us what cannot exceed or must be obeyed. Now, how, even though we want to, okay, this is what we want to do, but we cannot exceed this. This is how much we have. This is how much we're putting into this. So that is a constraint. So by general, you can see constraint is any condition that a solution must obey. Very simple. So now we have a constraint. In this solution, we have constraint. And what are our constraint? Number one constraint was we look at constraint one. Constraint one is going to be the what? We have, let's come back to this guy. Here we'll see. We have 2 units, right? Now, what do we need here? Now we have vitamin A, which is of 2 units of vitamin A. Understand that's what it contains here. This is what we have for this food. 2 units of our constraint A. And at the end of the day, what we are trying to get at the end of the day, we need to get 8 units of this. So after we mix all the food, what we are getting at the end of the day is 8 units of vitamin A. So let me form the constraint and then I'll explain it. So this will be like 2x1, that is 2 units, right? And plus 1x2 is greater than. So that is where we are reading that stuff and I was talking about inequalities. So what we have here was is supposed to be uh greater than or equals to, right? The greater than the equals to that is written like not like this. But this, what I'm trying to explain is like this is greater than or equals to in inequality, right? That's what it means. So it's supposed to have greater than equals to down and equals to 8. That's what it means. So the 8 here now is what we're supposed to get at the end of the day. Now, so okay, if you look at it now from this guy here, right, what this means is like Food one is going to produce 2 units of vitamin A per kg, and then food two is going to provide 1 unit of vitamin A per kg. The total of what? At least 8 units at the end of the day. So that is why I have this. So here, this is sorry, this is going down, down, down. It's making I need to just reference this guy. So you can see the two is for here, it's the vitamin A, and then the one is for the X. Remember X1, thank you. X1 is what? Food one, and X2 is food B. So now we have two and one. That's where we have this, and at the end of the day we have eight here. So we need to form the other one too, right? So the other one here is going to be 1x1 plus 2x2, 2x2. Now the x2 here, you see the two supposed to be very downward. This is system, so which is greater than or equals to, greater than or equals to what? What I was supposed to get at the end of this one is supposed to be 10 past 10. So we are forming our constraint. So now I want to pause and ask, do you understand from this to this level? Do we understand to this level? Do we have an idea of this idea to this level?
Yeah.
Okay. Okay, so let's let's just move on and just do it. Someone to ask a question. Okay, someone just joined.
Hello, good day.
Okay, yeah, good evening.
Good day. Can you hear me?
Yes, I can.
Okay, good afternoon. Please, can you just take it again? I'm actually a bit lost. So sorry for dragging you
From
back.
where? From where do you know?
From the beginning, oh, truthfully.
Jesus.
Sorry.
How many people are in support of that? You know, go by. Okay,
Yeah. I wouldn't mind that actually. I mean, I get it, but it wouldn't be bad to go over
okay,
it again, at least
okay,
from
okay, fine.
the cost formula to the constraints,
Okay,
that part.
okay. So the person that's actually come, I'm starting from the question, right? Or let me start from explaining what is linear programming, right? Are we together? Person that asked
Yes,
me.
yes.
Okay, so this is
I can hear you.
yeah, this
Right
linear
here.
this question we're looking at, it's actually past question paper, right? And the past question paper is from 802. And 802, if you look at it, more the three of it, it's more of calculation. Saying that's why people were like, okay, can we do tutorial later? So now we had a tutorial on network analysis. We have solved the network analysis issue, and now we're having to look at linear programming because most time these questions they come together. If you see network analysis question, then the next one you see it's network analysis, it's linear programming. So now, what is linear programming, right? And the linear programming is actually it. Let me make it in a very simple way, like in a very simple understanding of what I have. It's actually let's just say this is just a technique that help managers to use limited resources wisely, right? Because I want to do a project, I want to produce something, but then I don't have too much. I don't. The idea of everything I want to do is that I want to minimize my cost of production. That's what it means. So when they want to do that, they now use linear programming to do this. When I did this in my, this should be my 300 level course, operation research. That is 3 or 5, I guess, when I was in university. So now, what happened was we actually, okay, we did it this thing on the book, on like, theory like this, writing it on paper, solving. But then we also have, there's another tool for this, right? There's a system, let's say a program that helps to solve this. All we need to do, if we have that program now, all we need to do is to just put these values and it will give us the answer that we're going to get at the end of this, what you're doing here. That's just the idea. There's a system for this already for operation research. So they can, so managers can use that, put the values there, and then bam, they'll get what you're looking for instead of solving it. But now we don't have, this is a paper exam that we have to sit down and write with paper and pen. So we need to know how to solve it step by step. So I'm trying to see how I can explain this in a very simple way and with example. And the example that I'm using here, it is the past question paper. This is from a past question paper that I'm seeing this, right? It's from a past question paper. So now we are looking at the question here. It can be a different. I have another past question paper that is not talking about these food things. I think it's about another project. But let's look at this one. So let's say let's we now we want to cook, we want to mix some, we want to mix two types of food in a such a way that the vitamin in those food, in the food we are mixing at the end of the day, contain the content of the vitamin of the mixture contain at least 8 units of vitamin A. Take note of that. And then 10 units of vitamin C. So we are mixing two food. That means we have food one and food two, right? The food one contains 2 units per kg of unit one of vitamin A and 1 unit per kg of unit one of vitamin C. Then we have another food which is two. This contains 1 unit per kg of unit what of vitamin A and 2 units of per kg of vitamin C. Now the cost, how much does it cost us now? It costs us 50 naira per kg to purchase food one, and it costs us 70 naira per kg to purchase food two. Then the question now is formulate this problem as a linear programming problem and solve it. So we are formulating the question. That's what we are doing. We are trying to build up. So now, as okay, let's look at the given data. So as okay, now we have food one and food two. Food one, what does it contain? It contains 2 units of vitamin A. Now, is this food that we are going to mix? Remember, we are going to mix this food and this food. So that by the time we make this food, remember, if we mix these two food, they are going to give us uh where is that it again? They are going to give us at least 8 units of vitamin A and 10 units of vitamin C. That's the requirement. That's what we are looking at. That is what we're trying to produce. So now, but what we have currently now, we have already have two food. We have this food bread. Now we went to the market now to buy the food. Remember, now we are going to the market now to buy the food. Now they said that food one, the content of that food one, it's 2 units per kg of what? Vitamin A. And then 1 unit per kg of unit C or vitamin C. That is what is inside our food. Take note. Now, food two contains 1 unit per kg of what? Vitamin A and 2 units of per kg of unit C. Now, if you go to the market now, I want to buy this food so that I start mixing. How many of this food would I buy that will give me this 8 units of vitamin A? How many of this food am I going to mix? That is what we are trying to solve here. So now remember, when we are going to the market to buy this food, remember that this food it costs you 15 naira per kg to purchase food one. Abi? It costs you 15 naira. And then 17 naira per kg to purchase food two. We have all the data. So now when I come to our solving now, all this thing I'm doing here, we are just trying to solve. We have not even started solving, we are just arranging the data. So that I'm just breaking, if I'm solving this in example, sincerely, I will jump some step. But here we are just learning. So I'm trying to just do the whole thing like this so that we understand. I can just go straight to the point and start giving my uh, objective, objective function here, and then I start solving. But then I need to break this down for everybody to understand. So now we have food one, right? Which is it contains vitamin A, this, blah blah blah. It's just the same thing that we have here. I'll put it here. And then we now want to uh, define our variables. These variables, we defined it. If you want to define your variables can be changed. A variable can be anything. If you want, they can say B1 and B2. If you want, they can say Q2 or Q1. It is variable. So you can decide to assign anything to your variable. I can use C. Do you understand? I can use a Q, anything. So this one is not even actually, but then when I'm talking about X1, you should know that X1 is I'm talking about kg of food one. I'm talking about food one. If I talk about K and X2, that means I'm talking about what? Food two. So now this is our objective what function. Now the objective function here is either to minimize or to maximize. And then when you are producing, you can only I am not producing to maximize my what? My cost. I'm trying to minimize cost. When it comes to cost, now if you go to another side, if you go to another issue, another problem where we want to maximize profit, what we have here now will be different. We will not be being minimized. Anytime you are minimizing, it is cost that you are minimizing. When you are maximizing, you are maximizing profit. I can't say, okay, I want to produce and I want to bring out the cost so high. No, all I'm trying to do is to reduce the cost. That is what it means. So I have to minimize cost, and then the objective function for that is z. The variable z is equals to 50 x1 plus 70 naira x2. What is x2? Food one and two. That's what it means. Look at it here. This 50 was for food one, and then 70 was for x2, which is food one. Right? So we look at the cost. So this was just me trying to explain this thing to you. So the cost here, what we have here is 50 per kg of food one plus 70 per kg of food two. If you're solving, you don't need to put this. I'm just putting that to just so that they can read and have a good explanation or understanding of what I'm saying. Right? So I should move on. So now after we have formulated our function, there's another thing in this linear programming that you need to understand is the constraint. Now I explained the constraint. I said the constraint are just our limit. The constraint you already know are limitations, right? They are limits. What you cannot exceed. What I cannot exceed. I already have a limitation. So should I move on?
Yes, please. Thank you.
Okay. So now these are the constraints that we have. Okay. Continue. Okay, so now after we now have our constraint, the next thing we need to convert this we need to convert this constraint into an equation. Right, that is the graphing now. We need to convert this into an equation. And what to say, we are looking at linear programming. So this equation have to be like a linear line. If you know mathematics, when they have out of a linear line, right? Straight line, Okay. So we need to convert that. So all we need to do here now, right? Now this the constraint here we did this is an inequality what constraint. Like this what we have here is an inequality. Now what I have here, that's why I say if I'm writing with paper and pen, I wrote 2x1 plus 1x2 is greater than or equals to 8. Now what that means is I'm not saying this is what I mean. Yeah, I'm talking about inequality sign, inequality sign, inequalities. How we guys see my system. Exactly. So this is what I was talking. This is what I'm talking about, right? This is greater than or equals to. But the system I'm using here is a system, so I cannot write this greater than and slash. Now that's why I wrote it like this, right? So it's inequality sign. Now, but what by the time you have it this way, you now need to convert it. So now we are supposed to solve this. These are equations. They are not equation yet, but now at the end of we are supposed to convert it to equation so that we can solve these things simultaneously. We are moving on. So now I have to say, okay, let's convert this into equation. So what would do for vitamin A? For vitamin A now, what we need to do now is to say uh, we have 2x1 plus, right, x1 x2 equals to 8. That's an equation. We have equation 1, right? Now I didn't put, if you notice I said 2x plus x is equals to what? 8. I didn't put 1 because now 1 is already here because when you have x, when I say x2, there's a coefficient of x. These two, this thing now comes to equation now, right? So what it means is that 2 is an 2 is what? 2 is a coefficient of x1, and then 1 is a coefficient of x2. But then me not putting 1 here does not mean is not there. Do you understand now? 1 is still there. It's not like I'm taking it. It's there. There's a coefficient of 1 of x, which is 1. So let's move on. So the next equation is we now have another one, which is we just pick what to say. So here we now have x1 plus 2x2 is equals to 10. So now let's solve. So that if I solve this guy now, right, what I'm going to have here is going to be, so let's just do this step by step. I'm going to remove this one first. Let's focus on this one. So now this is what I have. So now x1, when x1 is equals to when x1 is equals to 0, right? When x1 is equals to 0, on that first equation, when x1 is equals to 0, it means x2, x1 is equals to 0, x2 is equals to 8. Now ask where did I get that 8 from? Well, you know where the 8 is coming from, right? Sorry, are we still together?
Hello, yes, we are together.
Okay, so the eight
Yes,
that
we're here.
okay, so the eight actually where is it coming from?
When x1 is equals to 0 from
Mhm.
equation 1,
Mm,
2 times x1, but x1 is 0. So 2 times 0 is 0. X2 is equals to 8.
perfect. This person, you know maths. Okay,
Thank you.
nice. So now we will do for the other one and then we will see. So now what this means that just to explain this. Now when x1 is equals to 0, then x2 is equals to 8. Now what that means is that we are using only food one. Like for we are using only what food. What happened here? X1 is equals to 0. So what do we have? We are left with x2. Now what's x2? X2 is food what? 2. That means no food one is used here in this equation, like in this whole thing. So now when we substitute the whole thing, well, okay. So now when we substitute now, what happened? We put the value into the equation and then bam, just like the way he said, then we are good. Should I do so? We'll see. So now we have uh, now this one will happen. I want to substitute so that you see, so that you can understand it easily. So remember, I said when x1 is equals to 0, so x1 is what? 0, right? 2 times 0, 0, nothing is there. Plus uh, x2, just x2. X2 is equals to what? 8. You understand? That's what it means. So what happened here? 2 times 0 is 0. Then x is now equals to what? Sorry, x2 is now equals to 2. Sorry, 8. X2 is now equals to what? 8. That is why we now have that 8 there. Do you understand now? Okay, as simple as banana. Okay, so now, in another case, what if when x is equals to 0? Okay, if x2 now is equals to 0, if x2 is equals to 0, that means we are only using food 1. We are not using food 2. But the first one we use food 1, we use food 2 without using food 1. So now we're now looking at the so now when for this one is equals to this, and then we have what are we going to have? It's another scenario. Now we have uh 2x1, same equation, 2x1 plus what? The equation is 0. 0 is here now because we are looking at x2. So to 1 times 0 is 0, then equals to what? 8. Then here we now have now what we are looking for. We are looking for x1. We are looking for x1. So what this means is that it's going to be 2x1 is now equals to 8. Then you divide both sides by what? 2. Now if I divide 2 by 2 is what? 1. Divide 8 by 2. It will now give me x1 is now equals to what? 4. That's what I will have. You get now. As simple as that. Does that make any sense?
Yes.
So that's what we're putting this on the line, right? So now if we use so what this means on this one here, let me explain this one when I said this. Now, what this means is that if we use 8 units of food 2 and 0 units of food 1, the vitamin A required is what? We're actually going to get vitamin A. Because what the requirement that they give to us before, we need at least 8 units of what? Vitamin A. Do you understand? So what this means is like if we use 8 units of this food 1 or food 2, sorry, of food 2 and 0 units of food 1, then the vitamin A requirement will be met easily. Then this will give us a point of saying that now we need to put that on the map. Sorry, not map, on the line graph. So that is going to be like 0.8. We have this on this one, and this one is going to be 4 comma 0, because we are looking at the point. These are just the point. So this one is going to be, we are looking, these are just the coordinate point. So this is going to be 4 like this. So we have this, right? So now why are these points actually important? Now these points are used to draw the straight line representing what the equation that we have. So we use this point to draw the equation, right? Do you understand? So we move on to, that was that equation, right? So that was for vitamin A. We fixed the vitamin A issue now. So we move to another vitamin, what? C. Now the equation for vitamin C was this. This is the equation now. So we are looking at this equation now, right? This one here. So what this means is when x is 0, when x1 is 0, what do you get? So this is the equation. We have 1x1, right? Plus, we have 1x1 plus what? 1x1 plus 2x plus 2x2 is now equals to what? Um, Equals to 10. So when x1 is equals to 0, what do we have? Let's substitute just the way we did. So now what we're going to do now, x1 is 0, right? So this is 0, this is 1 times 0 plus 2x. 2x2 is equals to what? 10. Now we just do the math, right? So now we have 2x2 is now equals to what? 10. 10 divide both side by 2. Now what I'm going to have now? Okay. Hello guys, sorry, can you hear me
Welcome.
now? Can you hear me? Okay. So I was trying to explain this from here, right? So I now say, okay, now this is for the vitamin C, right? So now when x is 0, when x1 is equals to 0, right? That is when we are not producing what? X1 food. That means x2 is our x2 now is going to be equals to 5. That's all. Then when x2 is equals to 0, what do we have? Now we have 1x1 plus 2 0 is now equals to what? 10, right? So now what we have now is going to be 1x, right? Abi? So what are we going to have? If what is going to be our x1 when x2 is 0 now? When x2 is 0, somebody should tell me. When x2 is 0, what is going to be our x1? Simple math. So just embarrass me. Okay, sorry. Can you see my screen? Hello.
No, no, you stop sharing.
Okay, how about now? Can you see it now?
It's up now. It's up now. It's up.
Okay, so I was asking that. Okay, in this equation now, when x1, right? When x2 equals to zero now, what is going to be our x1? It's simple now. This is a simple equation. So when x is equals to when our our x2 is equals to zero, our x1 is going to be 10. That's all. Understood? Do you understand why we get 10? Do you understand why we get 10? Please, so if you don't understand, ask me. Let me explain before we move on, please. Okay, so I assume that you understand. So I will just move on, right? That's it. But we have not solved the question. We are not done solving, right? We're not done solving. We keep going down. Should I continue? Or we're tired of it already?
Sure. Go ahead.
Okay. So on this one now, we have zero. In the coordinates, we have 0 and 5. 0 and 5. And then here, so the 0 and 5 should be here. That's here. And then we have 10. 10 comes around in the coordinate. Okay. So now, continuation of what we are doing. So now we are going to look at we in solving it. We need to look at our feasible region, right? Now, the feasible region in this equation or this question is we want to look at where all the constraints are satisfied simultaneously. You understand? Because what we did, we just find the coordinate with this, and then now we want to solve it simultaneously to look at where all the constraints are actually what satisfied. So we'll just do that quickly and then we're done. So this were our equations here, right? So since we have these equations, uh, this. So we want to solve it simultaneously. So from this equation one, right? From equation one, what we have here, we have uh, x2, we have x2, from equation one, from equation one, right? So from equation one, we now what we do we going to do simultaneous equation. We have x2 is equals to 8 minus 2x. That is what 2x1, right? So we have this. Then what we do now, we kind of do substitution. Just put it in there. So we are going to substitute this what we have now into our equation two. Do you understand? Now, by the time we form this now, we kind of do so. Our equation two is this one, right? So now let's substitute this into equation two. So kind of substitute. We are going to substitute equation now. This becomes, let's say, okay, this is equation one, this is equation two. Let this one should become our equation what three. Let's call this one three. This one is two. This one is equation one. So now we are going to substitute equation three into equation one. Do you understand? Substitute two, three into one, into two, into equation two. Then what we now have is going to be equation two is x one plus 2x2. Understand? So instead of x2 now, we already have 8 minus 2x x1. You understand? Substitution now. So by the time we do this now, we now have is now equals to 10. That's what we have. You understand? So now we now solve this. So what we are trying to find now, we want to solve this to get uh we want to solve this to get equation. We want to get x1 here. So we can now do x1 is now equals to 2 times 6 is what? Sorry, 2 times 8. No, 2 times 8, 16, Abby. We need to clear the bracket that is here. My network like this.
Getting network issues.
My God, I'm so sorry, guys. I didn't even know that I was not in the meeting. I honestly didn't. I was just talking to myself. Sorry. Okay, so but did you see to this level, to this point? Did you see to this point? Sorry, can you hear me? Should I continue? Should I explain this? Because I don't think you've seen to this level. Oh God, sorry. Thought my mic was on. Sorry, my mic is off. Oh, what the fuck is this system? Talking to my mouse. Sorry, guys. Can you hear me now? Hello?
Loud and clear.
Sorry, my mic was off. I didn't even. Oh. Okay, so I was asking that. Did you see to this level, or you lost me from here? Okay, so what I was trying to do here, we are seeing how we can solve this equation simultaneously. So I have created an equation 3 here, which is to say x2 is equals to 8 minus 2x from this equation, from this one. So I'm now substituting, I now want to do substitute equation 3 now into equation 2 to give me this. So 2 times 8 to give me 16. Then 2 times 2 will give me 2 times 2x1 will give me 2x, right? So this is giving me 4x1. That's what I have. Then this will be equals to 10, right? So now when I have this now, I'm taking now I want to collect like terms. So I have to collect like terms now. So what I'll have now, x1 is I already have one x here, one x1 and then 4x1. So this is going to be once this should give me equals to minus 3x x1 because 1 minus 4. Okay, so it's supposed to be so dot the line. This plus this plus this. So this is going to be uh x1. That is going to be x3 one is equals to what? This is going to be equals to what? Now I have 11, I have 10 minus 6, sorry, 10 minus 16. Or let's just say 10 minus 16 will now give me minus 6. Is what I have. So with this one now, I will now have this equals to 2. This is going to be our x1. So x1 is now equals to 2, right? Simultaneously. So I can now take I can take this equation 1 here, right? I can take equation 1 and substitute this x1 now inside to get my x2. Or I can even take equation 2, which one needs to be easy for me to solve. But then I can just do 2x1, right? Plus, so now I already have x1, which is 2. So this is going to be 2, and then plus 1, 1x2 is now equals to, I have x1 already. So what I'm looking for is x2. So this equals to 8. So now what I have here is 4, right? I have 4x times this equals to 4, right? So I have 4x. So I have 4 here. I have 4 plus, that's 4 plus 1x2 equals to 8. So I'm just breaking it down for you to understand. So now from here now I can see you now have 8 is now minus what? I can now say x2 now is equals to 8 because I'm taking 4 to the other side. Then it's going to be 4, going to be 8 minus 4, right? 8 minus 4. What is going to give me? It's going to give me 4. So my answer will now be what? 4. Shikina, that's my answer. So now what I have now, I have my x2 is now equals to what? 4. While my x1 is equals to what? 4. My x1 is equals to 2, and then x2 is equals to 4. So we have solved that. So one thing you need to understand is the question. So now, but now remember, we have not actually solved this thing to know the cost, because what we are looking at is to minimize what the cost. So we are looking at the minimum cost of production. So that is now we just do the final point. We just do the final thing and then we are good, right? We just do the final thing and we are good. So we're looking at our objective function that we already have, which is here. But we have an objective function. Where is it? We have an objective function here that we're going to solve, right? So now let's solve this objective function. Say, okay, now we have x1 and x2. Abi? Very simple. So we just do the thing. It's now work. Abi? So now the first one, when we did not solve it simultaneously. Now remember, we already found our x and y's from this side. Now when we did this one, we wanted to satisfy both of them at the same time. Because somebody said, okay, you're doing Joe, let's just solve it simultaneously so that we get everything equally based on this simultaneous equation. So for us to satisfy this guy, remember, when x from this one here, we're using this coordination now, we're using to this corner point, we're using to this point. Our x1 is 0, right? When x1 is 0, so let's put it. First one, x1, where x1 is equals to 0, what we have now is 50 times x1, which is 0, right? And then what do we have? What do we have? Plus 70 times what? 8, right? So if you do this now, 50 times 0 is equals to what? 0, right? It's equals to 0. That's at point we're looking at this. Looking at this guy, uh, we need to do one point because we know we just can't just take that. It may not really work like that. Yes, we have 10 equals to 0, so we have the one. Okay, this is this one, and this one we are taking highest. Okay, so this is equals to what? Do the math for me, sorry. So if I do this now, I'm going to have uh, 70 times 70 times what? 8. It will give me 5 6. So this is how much it's going to cost. This 5 6 9 is in error. So this is going to be for what? Vitamin what? This should be for vitamin C. This is for C. And then I'm looking at, I have C here, I have C at the point. And then I have the next one, Z is equals to um, this one, which is this point. So looking at the highest. So, oh God, shit. So that is this one. I'm looking for this one here. So what this means is I'm going to have uh, 50. So now what I have x1. X1 now is going to times what? Times 10. And then plus 70 into x2. Then x2 is now 0. It is now 0. So what I have now is going to be 50 times 10. It's going to be 500. And so the last one is going to be for the minimal solution. By the time we do this step, we don't. By the time we do this simultaneous, this is the one we need to use to, because in this in this one now, I'm just trying to test everything here. Like this at this point in is what is called the evaluation of objective what function. We want to evaluate it at each point so that we can get the optimal solution. Now, but then the one we are going to use is the one that actually satisfies both x1 and x2, which is the simultaneous equation that we saw. All these ones, sincerely, you don't even need to do this. Everything I do here is just trying to break every step for study session, just for studies sake. But by the time I solve this now, all I need to do was to just do okay. 50 is equals to what's my x1 is 2, and then plus what is my x2 is 4. So plus 70 times what? 4. So I will come here. 5 times this is equals to 10 plus 70. So I can just do this equals to 7 7 times 4 is equals to what? 28. Then this times this is 10. So I can say okay equals to 10 plus this equals to 38. Right? Hello guys, are we together?
Sorry, I'm confused.
We are confused of from where?
From this 5 in bracket 2 plus 7 in bracket 4.
Okay, this is supposed to be
Why
50.
not 50? Okay,
This is
yeah.
supposed to be 50 and
Mm-hmm.
70. Thank you. So this will now give us what? So this is supposed to be 70 times 4.
4.
That is 280. And this is supposed to be what? 100. This one's supposed to be 100. So this
Yes.
is supposed to be 100 uh, times this. So now, looking at between this, remember we are minimizing costs. So which one in the objective function is more is more minimal? Which one is more simple?
380.
380. So 380 is our final answer. That is what we are looking for. So our optimal solution now, the minimum cost of this production now is what? 380 naira. Always put the sign. If you don't put the sign, I'm telling you, you will fail.
Okay.
Yeah, because we are looking at the money. So if I just say 380, your lecturer can assume it's 380 kg or 380 cows or 380. So these units are very important when, especially when you are solving stuff like this. So
Exactly.
yeah, so you just have to put the currency.
All right.
Very, very important. Make it naira. If you don't do it, lecturer will shine. So that's it. So that is what we're looking for. So 380 naira is our optimal solution. That's just what
Mm.
you're looking for. Sincerely. That's what you're looking for. So that was that particular question. We solve it and then think we are good. I have one other question here that with this simple explanation. Now, but another question, and I have another past question paper that I've been looking at for a while now. So this one too is more. Uh, you see, this one now they're already giving. They didn't give us like that kind of question. Can you see my screen? This is another past
Mm.
question paper, right? So now this one here, they're already giving. Now here's to maximize. They said that solve the following linear programming graphically, and then z is equals to 3x1 plus 2x this, and then subject or constraint. So this is this. So all those things will be forming from that problem now. They already there's no problem. They just give us the linear and the inequalities. So we just convert this to an equation, solve it simultaneously. So we'll be good. So this is when x is equals to 0 and x is equals to 2, just like what I have here. When x
Sorry,
is
I have
equals
a question, please.
to, okay, this
So
will be more simple.
what's the graphical answer?
The answer.
Yes, the graphical answer.
Now, what it means is that is what we already saw. Just that now,
Okay.
what it means is this is what
Okay.
we have here. Do you understand? It does not mean you must plot the graph on the graph.
Okay.
Now, you understand? That is why on the graph coordinate, that is why we have to form all those things. That is why we solve all these things. That is the graphic.
Oh,
This thing is that it's just the solving method of linear programming.
okay, I
So
understand.
that's what it means.
Thank you.
Yeah. So this is our answer for that question. If you see it anywhere and you solve it very well, you get that answer.
Okay.
Yeah. So like this one now, like this question I just show you guys now. Where is that past question paper again? Is it this one? Yeah, this one. If you look at this one now, it's straightforward. It's simple. You can solve this question for from this example that we just have now. You can solve the question because you have two equations here. And this one here is your objective.